In this video, we'll be looking into learning about the sine rule and the cosine rule, which we'll be applying to scaling triangles. So, if you don't know the meaning of scaling, its difference is that it doesn't have a right angle. So, any triangle that we already talked about, where applying the sine, cosine, and tan ratios applies to right angle triangles. But these rules, when we talk about a rule here, sine rule and cosine rule, it will apply to scaling triangles. That is, there is no right angle in this triangle, but yet if we know certain sides and certain angles, we can figure out the missing side and so on and so forth. Okay, so let's say we have this scaling triangle here, and the way you label this triangle is that capital A all is labeled for the side opposite to the side that is labeled small a. So notice, and capital B is always opposite the side that is labeled small b, and capital C is always the angle opposite to the side that is labeled small c. So this kind of labeling, please do that always. We stick to the convention here. Mathematicians just decided to do that for a reason, because this sine rule and cosine rule wouldn't make sense otherwise. So when you this association, you have to learn it immediately uh, and do it now. Now let's say we have labeled our triangle there. This is our scaling triangle, right? But we're going to be clever about it and divide it into right angle triangle. I'm just gonna put a dotted dashed line there in the middle. And now we got two right angle triangles. We divide into two right angle triangles there. So now you can say, I can use the rules I learned with right angle triangles. If I also divide this bottom side of it, this label called C, we're going to divide it into x and c minus x, right? Because the length x here is a length, so whatever c was, if we take away x from it, we don't want too many unknowns here. So we're just going to leave it as c minus x, rather than give it a new name like y or z or whatever. Because geometrically, it would be c minus that side there, x. So now we can say, what's the definition of this height here? This h stands for this height of this triangle ACD. So it's height that is opposite, and this side here would be we would just use the Pythagoras theorem, right? We'd say c square minus b square is a square. All right. So we just saying that b square minus x square is this h square. Okay. This don't get confused with c square. That's not talking about this c here. That's just talking about the Pythagorean triplets there. That's so let's just say that our Pythagorean triplets is b square. This longest side, hypotenuse, minus one of the shortest sides will give us h squared. And if we do the same for the other triangle there, apply just Pythagoras there, h squared is also going to be a squared minus c minus x in a bracket squared. Alright, so we're going to set these two equal to each other. So we're going to have b squared minus x squared. This is one definition of h squared. Now I'm going to use the other definition. Definition number two is going to be a squared minus c minus x squared, like so. Alright, so we're gonna set these two equal to each other, and then use the cosine rule to figure out what they are. Alright, so I'll show you that on the next slide here. So I can show you the definition working out here. So if we expand this bracket, what we're going to have is a square. My I'm just going to expand the bracket and uh, put them inside the bracket here. So because that minus sign will have to be distributed. I don't want to confuse you. All right. So we get 2cx here and positive x squared. Don't forget, because when you just expand this bracket on the side, you see you get a positive x squared. But that minus outside the bracket will have to be distributed. So I'm gonna leave the left side of this equation as it is. Here we've got a squared minus c squared minus 2cx. Now that will become a plus 2cx. Now cx or xc is the same thing, and then this will be a minus x squared here. Alright, that minus is important, that is distributed here and here. So the signs change because of the minus on that side of the bracket. Now what we notice is that we got a minus x and a minus x squared on both sides of the equation. Alright, so we can add x squared to both sides and those two will cancel away. So our equation is looking like b squared minus c squared. B squared is a squared minus c squared plus 2cx. Alright, so what's what's strange is that we don't have an x really. We because we got the x from right angle triangles and we didn't really have that dashed line there. So we're gonna go back to this triangle here that we devised for ourselves. This red triangle here. This is a right angle triangle, and we can use the trick ratios here to help us. So we want to know what's this side x here. So this side is adjacent, right? This adjacent here, and then this adjacent side, and that's the hypotenuse there. All right. So we can use the say this angle here is cos. So cos of capital A is going to be our x divided by hypotenuse, and which is b. Okay. So that's why we can rearrange it and just say x is b multiplied by cos A, right? So this is x. Our definition of x is b times cos A. So I can bring it down here. I can rewrite this rule as b squared equals to a squared minus c squared plus 2c 2cd multiplied by cos of A. Alright? So now this rule, you have it. We have it written for b squared here. Now you can rearrange it if we used another angle there. If we were measuring angle b rather than a, what what would have changed is that this a little a and those little b would swap sides. So then, actually, to use it, you would take the square root of both sides. So you would, at the minute, if you were looking for side B, we would use this angle here. So it can be rearranged. If we had angle B there, we would have A and B swapped with each other. So we would have A square equals B square minus C square plus 2, instead of B, we would have used little a here, and instead of capital B, capital A, we would have used capital B there. So do you understand how you can swap the sides? So if we were looking for c squared here, c squared, we would swap its place with that b squared there. Alright, so and then we would so every time now I see where A is, I'm gonna swap it with C. So B square I'm gonna leave alone. So here I would have A square plus 2, instead of C I have to use B and A, and here I would have to use cos of capital C. Now there is another way of rearranging this equation. if you're looking for angle cos, now if you rearrange it, cos of capital A will be b square plus c square minus little a square divided by 2bc. Okay, so this is the way I remember it. If you just go through the rearrangement, there is a minus sign, then there would be a minus sign in the denominator, then you divide everything by a minus sign. It will turn out to be this. And if you're looking for one of the sides, this is how, like, if you had to, like, if you think about it, look at a square. This is this formula here. A square. The in front of cos b, we would have. Sorry, that would be. Uh, so here we go. Here we have used this. If you weren't sure what I was pointing at, I was pointing up here at this x here. All right, in upper above the page. So I replace that x with b times cos a. Now, in general, if you the formula is written like so. If you think I'm gonna add uh, keep a square on one side, and then everything else will be like if I keep a square here, I will have b square plus c square minus 2bc cos a. This is the general form of the formula you will be given. So a square equals to this. Just try to remember, if you have if you're looking for one side of the triangle little a, then you cannot have little a on the opposite side as well, can you? So everything here on this side is in terms of B and C, and you only have a capital A to work with. All right. So then, if you remember this format, then the rest of it it's the same. B square will be A square plus C square minus two lots of AC multiplied by cos of capital B here. And if you're looking for c square, you have a square plus b square minus two lots of ab multiplied by cos of capital C here. All right. So remember that, and rearranging that. So cos of capital A is going to be always b square plus c square minus a square divided by 2abc. All right. So this the bit that is here, this capital A is, if you think about it, there's only little a that we're subtracting right at the end. All right. So these formulas are not in your formula booklet for examination. They are for IGCSE and GCSE, but for A-level maths, you just need to memorize these. Okay. So I'm afraid that you do have to use your memory and remember one form or another of this equation and rearrange it for yourself. Alright, so next I'll show you the sine rule and then we'll learn when do they apply. The following section, I'm just going to show you the proof for the sine rule. If you're not interested in the proof, you can fast forward and find to where I explain when they are applied. But it's quite interesting to know where they come from. So once again, we've got a scaling triangle here, and we've divided it into two right angle triangles by drawing a vertical line in the middle. So now we're going to cover this up and just say, if I'm looking for the opposite side of this right angle triangle here, I have to take and I know the angle there, I'm going to multiply sine by hypotenuse to get the opposite side. So I write here the definition of the opposite side. One way to think about it, hypotenuse is A, and sine, remember labeling our original, let's go back, our original triangle has C, little c opposite capital C, capital A opposite small a, and so on and so forth. So remember how you label the scaling triangle there. So we're going to use as our hypotenuse, and sine C is sine of this angle here. So that's one way of figuring out the opposite. Now if I cover up the other side of the triangle and use this other right angle triangle to figure out the opposite side, it will be little c multiplied by sine of capital A, right? So these are two definitions of the opposite sides. Notice we're working with this line here, and these two are two opposite sides. So we can just ignore the opposite and set this a sine C equals to C sine A. So let's just set them equal to each other. So we can rearrange it any way we like. Notice the similarity in the names, so in the letters. So we can divide both sides by A and C. So we'll end up with sine of A capital A over A equals the sine of capital C over C. Now if you rearrange this another way and you cross multiply by a and C. This line here, if I divide by sine A and sine capital A and sine capital C, you end up with C over sine of capital C equals to little a over sine of capital A. So that's another way of rewriting the same formula. And of course, if you didn't have a C and you had a B, you'd end up with this version. Okay, you only need two of these fractions to work with. So when you see what's appearing on top of the page here is this rule here. You only need two of those fractions to work with, not all three. But it's just saying the rule works for any corresponding sides. Okay, and you either use this rule or that rule there. All right, so now we can learn when to we use uh, of these rules. So actually this video is getting a little too long, so I'm going to uh, uh, pause the video and make another video to teach you how to use them.